Hello everyone, this is another student's quest, but this time not the problem from JTA. This question was sent to me by one of the student, and the student wants to clarify that how the second derivative of any homogeneous function is 0. So you can notice there that this is the function here, which is a very complicated way they have expressed the x to the power 5 log y by x, y to the power 5 cos x by y, x square y cube, and so on. So if you go by the usual method by finding the second derivative, like by finding the first derivative and then the second derivative, it will be a very tedious task. But we also know that many of the students might have known this thing, that whenever we have a homogeneous homogeneous function, then the second derivative will be always 0. But the problem is how. So let's try to understand. First of all, what is homogeneous equation we have to understand. So any function, suppose I'm writing f of xy is equal to 0, is a function of xy, and suppose I'm taking for any lambda, any non-zero lambda, if I replace x with lambda x and replace y with lambda y, and if I get that lambda to the power n f of xy, then we say that function is homogeneous. This is the basic definition of the homogeneous function we have in this particular situation. Suppose I have this f of xy, I'm taking this entire thing. What I'm saying, that this is equivalent to f of xy comma 0. It means I'm calling this entire function on the left hand side as a f of xy, and then substitute x with lambda x and y with lambda y. So let's substitute it. So lambda x and lambda y. So what we get here is lambda to the power 5, x to the power 5, and their log. And you notice that their y by x will become, because we are substituting lambda x and lambda y, so of course lambda and lambda will get cancelled, so we get y by x minus lambda to the power 5, y to the power 5, cosine of, again this will become x by y, doesn't be affected, will not get affected rather, and this is going to be again lambda to the power 5 x square y cube. And in this square root also, you can see this is a degree 2, this is a degree 2, and this is also degree 2. So if you substitute this lambda x and lambda y, we get the same expression because they have same degree. So when you realize that this is actually the play of degrees and all, so why not we can just generalize this thing, that if each term has the same degree, then the function is considered to be homogeneous, and this is one of the way to define the function which is homogeneous. So what is this thing that's happening, that you see that the power of x here is 5, and inside this any function log, which is not a polynomial function, inside that y and x shares the same degree. This power, this entire expression has the degree 5, if you want to say like that, because log y by x, inside that y and x are the same degree. Similarly, this has power 5 because the cos has x and y and they have the same degree. Similarly, this has power 5, and the entire this expression inside the square root has the degree 2 because this is 2, 2, and this is 2. So all these upper and lower values have the degree 2, so that lambda will get cancelled. So what you notice there, that after substituting this lambda x is equal lambda x and lambda y in the place of x and y, then what is going to happen here? We can take this lambda to the power 5 common, and we are getting there x to the power 5 log y by x minus y to the power 5 cos of x by y, and plus x to the power 2 y to the power 3, and it's the same thing there. It means what we observe, that we are getting the same function back here with this property lambda to the power 5 and then f of x comma y. So don't you think that we have substituted lambda x lambda y, I don't need to say that. I should not say like equal. This is actually, I'm substituting this with that. So what we get it here is f of lambda x lambda y is equal to lambda to the power 5 f of xy. So this is exactly happening by the definition. Means this is exactly following the definition, by the way. It means this function is homogeneous. Now if the function is homogeneous, what is the benefit of it? If the function is homogeneous, the benefit of it is that, let me just take this question again, copy it down there, then I will explain. So if the function is homogeneous, and you notice I can write y with, I can replace y or write y as some constant k times x, and then what will happen, that I'm assuming that the y by x, because the homogeneity is a constant k. But this constant is not a fixed constant. Basically this is actually arbitrary constant. We can take anything. We'll come to that. So what will happen to this is, when you write this thing, x I'm not changing, I'm writing x to the power 5 only there, and this log k will come there, then minus again what we are getting there is y by y is equal to kx. So again kx to the power, so k to the power 5 x to the power 5, and then I have cos of y by x, so cos of k, so cos of 1 by k rather, and then plus this is going to be x square. So here putting the y is equal to kx will become x to the power 5 and then k to the power 5. And similarly here you substitute, so you get x squared common, so we get 1 plus k squared, and here the x we are substituting with kx, so x squared cancels, will become k, and that is going to be 0. Now we notice x to the power 5 I can take common, and we get log k minus k to the power 5 cos 1 by k plus k to the power 5, and this is going to be 1 plus k squared by k. You notice that the x cannot be 0. It means that if x not equal to 0, this is the equation I have to solve to get this equal to 0. It means now it is a single variable equation, and single variable equation means k. It means we can get the values of k. Suppose I am getting k is equal to k1, then k is equal to k2. It means all these solutions are actually some fixed quantities of k. Usually actually we have taken this k as a constant, but this constant is still a variable constant. Means variable constant is a wrong word, I should say arbitrary constant. Means these are still unknowns, actually that's the correct word. So k are unknowns, but in order to find that k, it means we are finding the y by x actually. So each y by x in the process of finding, suppose this k has this solution, this equation we are getting as, let's say 5 different values of k. So for each such k, y by x is a constant. For each such k, y by x is a constant. It means now we can say that we have already known y by x is a constant. It means each such y by x is a solution of this equation. So already I know that whatever you do, I have y is related to x in this way, that y is equal to kx. It doesn't matter what relation you make it complicated. And in implicit derivative, this is actually the idea that the y, the dependent variable is connected with dependent variable x, but in implicit way, and our aim is to find the first derivative. It means we are applying the chain rule, but here it's difficult to apply the chain rule, so we are thinking in a different way, that can we find out any other way to relate y and x. So we actually discovered that y is related to x with the y is equal to kx rule. Why? Because every such y is equal to kx is satisfying this thing. It means y by x doesn't matter what happens to the constant. If y by x is a constant, we can also find like this, that the y is equal to kx, and so the dy by dx is going to be k, and so the second derivative is going to be 0. I hope it makes sense. The other way to think, that already we have y by x is equal to k, it is representing a straight line which is passing through the origin. If you notice that if I say y is equal to kx, it means the slope of this line is constant k. Maybe the constant k means like a slope. If you say y is equal to mx, the m you say that is a constant, but it doesn't mean that is always fixed constant. It's arbitrary constant, or for every arbitrary constant derivative is 0. So in that way also you can think that this line has the slope already dy by dx is y by x, because this is the slope, and slope you know, this is dy by dx. So dy by dx is already y by x. So let's find a derivative again. So we go, what we get, second derivative in this way, what we get, x square x dy by dx minus y times 1. Now dy by dx is already, I have y by x, so substitute there y by x there, and we get the same thing as a 0. In order to understand this thing more clearly, let's try to find out those y by x values by taking some lower degree polynomial. Maybe in this complicated and integrated kind of what we call the complicated kind of a structure is not so intuitive, but if we understand with some easy example, then will be okay. So let's say I have an equation x square plus 5xy plus 6y square is equal to 0, and I have to find the second derivative of it. Okay, so means dy, we have to again find d2y by dx square. So of course we can do by the process. Let's try first this thing. So x2x plus 5 times x plus, sorry, x into dy by dx. So x y dash I can write plus y, and here 12 y dash. So what we get, the y dash, we see it, but let's again differentiate one more time to find the second derivative. So we get it 2 plus 5, and here we can write to x to y double dash plus y dash, and again plus y dash. Here apply the product rule. In this step I am applying the product rule, so we get this 2, and this is y double dash, sorry, y dash, and here I get again the product rule, so y double dash plus y dash square is equal to 0. Now in order to find y double dash, what we do, we rearrange it, and again we actually take from here some y dash value and substitute it there at the place of y dash and all. So the idea is you do it and you can get this second derivative is 0. And why it is so, let's try to understand a different way. Different way is this one. Suppose I'm taking this thing and I'm dividing, let me write it again, x square plus 5xy plus 6y square is equal to 0. By the way, I'm not going to do this kind of thing because it takes time. So let's see here. What I'm going to do is I'm dividing by x square. So we get 1. Then this will give you y by x, and this will give you 6y by x whole square. So in this what we got is 6, and I'm calling y by x at some other variable or constant, whatever you want to say. Let's say v. Let's say this v is a variable only. So what we got it here, 6v square plus 5v plus 1 is equal to 0. Can we factor it out? So I need this thing 6v square plus what we can write? We can write 3v plus 2v and plus 1 is equal to 0. I can factor, so we get 6v plus 3 and plus not 6v plus 3, rather, what kind of thing I'm doing? This is 3v, so we take 2v plus 1, and here also 1 and then 2v plus 1. So we got two factors. The factors were 3v plus 1 and 2v plus 1. So what we are doing there, we are doing there v is equal to minus 1 by 3 first, and second what we got, v is equal to minus 1 by 2. It means we got there that the y is equal to minus 1 by 3x because v was y by x, and here you get y is equal to minus 1 by 2x. Now suppose someone asked to find out the first derivative. For that, from there what we get, dy by dx is equal to minus 1 by 3, and here what we get, dy by dx is equal to minus 1 by 2. Now you can tell that why, if I suppose differentiate like this, why we are not getting this? We are getting it. Actually, this is y dash is equal to minus 1 by 3, and this is also y dash minus 1 by 2. Can we not write 3y dash plus 1 is equal to 0? Can we not write 2y dash plus 1 is equal to 0? And when we combine this thing, we get a relation. So these two are actually the different derivatives, and that's why you are not getting this first derivative as a constant, because this equation will provide us. And also there's a, notice one thing, that in this equation there's a x is also involved, so I have to write x back again, and there's a x also. So there are a lot of things we have to manipulate to get these two factors in terms of y dash. But what doesn't matter what y dash is coming if you differentiate it further, because since y dash is constant, or any constant you take, the derivative will become 0. So this is the whole idea about this. So the second question, I think this one, let me copy this thing. In that, so this was the second question actually. So you can also notice the same thing here happening, because now this is a degree of 13, because when you substitute y is equal to lambda x there, so 13 will come, and then again you have to apply the similar kind of process. And you notice also by the degree check that this has degree 2, this has degree 2, this is degree 2, this is degree 2, and this is an alien kind of function, is not a polynomial. So inside that alien function, I should not say alien, but still sine inverse, and this inside there's no actually this numerator and denominator shares the same degree. Similarly, this is sec trigonometric function, inside the root again this x and y shares the same degree, and here also the same story is happening. But from there you can also think that this degree is 13, and here also degree is 13, because each has degree 26 and we are taking the root of it. So since it is actually a homogeneous function, again we can take the second derivative as 0. Alright, so that's all for today's Student's Quest. I'm getting enormous amounts of emails and the WhatsApp messages full of many doubts. So it's just a matter of time. When time is in favor, I will definitely solve all those problems. You have to keep watching, and also I cannot promise, if you get the solution by yourself, that please go through it, don't wait, because I cannot promise that when I will publish. So that's the thing with me. So thanks for relying on me and sending me these much emails, because this builds a trust, and I'm really overwhelmed by all your respectful emails and messages. So see you in the next video with some other Student's Quest. Stay math active.